Hi folks, welcome to another episode of NYC CNC. Today, I want to go through some of the really cool improvements we've made on the GRBL Arduino CNC machine. Two major things. We've got a controllable Z-axis for the pen with a dual spring system. I think you're going to like it. It's pretty easy to do. I want to show you how you can do it. And then ChiliPeppr. Oh my gosh, people said to mention it, to use it in the last video we did on this, and ChiliPeppr is amazing. It is the GUI and interface to use with the GRBL Shield or the Tiny G is mind-blowing. I had no idea. Folks said you'd like it. That they were not kidding. So let's dive right in and take a look. For fun, let's take another look at drawing out that logo again, a little closer look at the machine. You remember last time, we basically did the same thing, except we didn't have any way to lift or control the Z-axis. Now you are getting some jerkiness in the text here. I'm going to talk about that a lot during this video because there are ways to improve it both in this design and the next machine. I'm also okay with it because the point here is this is an incredibly inexpensive machine. And look, just how cool is that, folks? Just freaking amazing. And the only time we really had problems is when you are coming in and out of a curve or you're running two at once. And honestly, a lot of it has to do with I've just got too much slop in the, especially the Y-axis that's traveling along the X here. So you can see I can move that, and that, as that drags that tip, and this has a little bit more friction than like a felt tipped fat Sharpie. It's just creating that wobble. The easy solution would be to have two instead of one of these little ball screws along the X rails, so making these brackets wider wouldn't be a hard thing to do, just didn't happen on this machine. But super amazed. So let's take a look at both this little Z-axis plunger system and then ChiliPeppr. I put a lot of thought into this Z-axis pen mechanism. I wanted something that was simple, but I wanted it to be reliable. And what I realized was you're going to need basically two springs, and here's why. This bottom spring here that you see right there, the thinner one, its job is to lift the pen way off the paper when you need to rapid between positions so that the pen is not coming close to touching the paper. So that's the sort of up and down, binary down or up position, if that makes sense. But we also need a second spring to accommodate for the cushion of a lot of things, of the felt tip of the pen or whatever type of pen you're using, and for the exact position of this arm that we're using on the stepper to activate it, and for undulations or uneven surfaces in the paper or material itself. Because if you think about it, if you tried to take the hardest example, like an actual little ballpoint pen, you would basically have to have exact, constant, even pressure, and that's really hard to maintain across much of a surface. So again, nothing complicated in the end. This is what I came up with. We've got this machine sleeve, and that's what holds the pen in it, and then we just glued this heavier spring on top, and so as you can see what happens, I'll actually go ahead and move the Z-axis down here, G01Z -6. You can see we've fully compressed quite easily the low spring, and then the high spring has tension on it, which will allow the pen to move over the paper pretty evenly. I also just like it because it's simple. You can basically put any sort of pen that you want inside of here. This one is actually just secured right now with wound up electrical tape for friction fit. I would actually recommend gluing one in there because that's going to provide an even tighter fit than this pen's got right now. Another probably reason why we've got a little bit of wobble in the drawing. So what we're going to do is we're going to sell this little Z-axis kit. It'll have the angle bracket here machined so that you can put in your stepper motor, this little piece here, and then the bushing with the two springs. It'll also have the block here. So you should be able to basically just hook it up to your system, whether you buy it or make it yourself. And what you can do then is we'll also sell extra bushings, so they're not going to be expensive. And if you want to make dedicated bushings for each pen, then you're good to go. Quite simple. Again, I think it's a good way to go, but tape will work fine in a pinch. Let's talk ChiliPeppr. As you guys remember from the last video, we were using this universal G-code sender. No complaints, God bless them, it worked great, but folks have mentioned in the comments, check out ChiliPeppr, and folks, God bless you, it is unbelievable. The GUI's right here. Before you can use ChiliPeppr, what I want to do is show you how to get it running, because just like the GRBL and other stuff, it's not hard, but a couple tricks. What you need to do is Google or go to the link in the video description for this serial port JSON WebSocket. Sounds complicated, Don't worry about it. Don't overthink it. I honestly read almost none of this. Just go to binaries for download in Windows or Mac, whatever, X32 or 64-bit. You download it. It's a simple, what is it? It's just an executable file. When you double click it, you get this little screen right here, and it lists your 2 serial ports. You'll see Arduino Uno and then on COM12. So in, sorry, and go to ChiliPeppr, you can see is right here. We're using it on GRBL. I wanted to actually, good time to mention, I know folks have been frustrated that the GRBL shields are right now sold out. They've been incredibly popular. I talked to the folks at Synthetos. They're just experiencing growing pains. I think they're moving one of their vendors or something. They're definitely expect them to be back in stock, so don't give up hope. They make a great other board. It's unfortunately a little bit more expensive. If you're really, you know, rushing to get out, check out TinyG. Again, it's more expensive, a lot more powerful. I've got one in my drawer I've been anxious to play with, but it is available if you can't get your hands on a GRBL shield for now. So once you go into GRBL or ChiliPeppr, you choose GRBL when it asks you. What you'll then see is down here on the bottom right is your port list, and you just check Arduino Uno, and that will get you connected. Now, it's a wonderful GUI. However, I did find it, after I spent an hour with it, it made more sense. Took me a little while, though, prior to. So one of the things you'll notice is you've sort of got these workspaces or stickies or whatever they call them all around your center area with the the CAD file itself. So real quick, I haven't played a lot of this stuff, but it's amazing. I mean, look, it can send you a text message when your job is complete. If this is a really long, like a 3D print job that takes multiple hours, that's pretty darn cool. A couple of little things here that aren't matter, or that I don't pay attention to right now, at least. This is how you start, stop, and rewind the G code itself for the file. We'll come back to that. And then on the bottom left, this is your sort of what I call the MDI, or basically where you can type it to go, say G01, X100, F5000, and 5000, enter, and that'll manually control it. On the top right, you've got your axes where you can zero them out, go home, or manually jog. The jogging is not strange, but if you click on jog, then the keyboard will let you jog, or you can expand this thing, which is a mouse scroll area. It's interesting, but I don't know if I love it. You can change your jog increments. You can jog by clicking on here, set custom increments. It's great. I don't want to complain, but it's something's a little quirky to me about it. Very importantly, here's where you control the GRBL itself. You can do a soft reset with that button. Clicking on this button pops up those settings that you used to have to deal with in sort of that DOS equivalent setting. They have warned you that it may not work perfectly, and I actually did want to check it a couple times. It didn't hold the settings. But now is a great time to go look at it. We're using NEMA 17s. Links are in the video description. And you can see, we're doing 8 microsteps on the GRBL shield itself, which means there's no jumpers across those pins. And then you can see, I think the only settings I had to change were these for the steps. And if you guys remember, we had that Excel file that I shared from the first video. And the math is quite simple. We say if 1600 steps, that's 1 revolution, because we're using 200 step steppers, and we're micro stepping 8x, so 8 times 200 is 1600. That on my machine went 1.256 inches. I literally just measured how far it went. That means that's the metric equivalent, which means 1 millimeter takes 50.15 steps, and that's the equivalent there. Okay, let's spend a few more minutes in GRBL taking a look at some pretty darn cool things it can do. First of all, you see you can click control and it jogs to that point. So control click, boom. How cool is that, folks? And it's just incredibly useful. It's just amazing to me. Now we want to go back to 0, click, go to 0. Actually, to show that off, go back over here and we can click go to 0. Now, one of the things I spent a lot of time with trying to get was this smooth motion, and we'll take a look at some manual code, and you can see if we type in G01, X150, F1000, it's not going to be as smooth. Well, I shouldn't say that, but you can see it's kind of got that hum to it. Now we type the same thing, go back, G01X0 F6000. Listen to this. See how much nicer that is? Now it's probably just the pulse rate. Someone might chime in on what the expert reason is, but I basically like how smooth it seems at that higher feed rate. So let's do this. Let's really quickly show off how we can write a basic G-code program so that folks can understand how simple that is. So we're going to start, there's two different commands. G0 is rapid, and G01 lets you control how fast you want to move. So G0 is going to move basically as fast as the machine lets us, which is the setting we defined right here. So in our notepad file, we're going to type in G0, X0, Y0. In fact, what we're going to do first, make sure the pen is lifted up. So G01, Z1, I think was what I was using. Let me take a look. That should be fine. So that lifts the pen. This puts us to the home position. Now we're going to put the pen down onto the paper. So G01, Z, for me it's -6. We'll just do F750. Then we're going to draw a box. So G01, X175. That'll go right 175 millimeters. And we're going to set that at feed rate of F6000. Now, G01, Y -75, we don't need to type F6000 because it'll carry that through since we haven't, until we change it again. G01, X0, G01, Y0, and then we'll lift the pen up again. G01, X1, F750. We'll save that. So now here's what's really cool about ChiliPeppr. We're going to grab that file and just drag it here, and it's going to drop it in, and it's going to say, hey, one of the things you need to do in G-code is tell me whether I'm dealing in millimeters or inches. As a layman, I'm kind of like, I don't want to deal with that stuff. And so what it does is it automatically will add that for you. We're in millimeters, boom. And if you look, there is our shape. How cool is that? So without further ado, let's see what happens. Well, actually, we'll start in here, so it'll go back to the home position just to show that off. Pretty cool, right? Okay, so again, you see the little variations in that line right around the corners. So that could be done, like I mentioned earlier, be improved with a little bit more rigid axis. But the other thing I wanted to mention, folks, is the next project I'm super excited for is we're going to build a same type of machine, but way more rigid, really a proper almost CNC type machine that we're going to use for, well, I'm excited. I'm going to keep it a secret until we come out with it. But we've got a nice ball screw here. These are preloaded ball nuts that are very low backlash, very precise ground things. These are what you see in machines like Tormach's. And we're going to use linear rails. So these, again, have ball nuts in them. These are hardened ground rails, and they're low friction, so they slide back and forth real easy, but you can't twist or move that at all. So completely different machine, but you know, one of these alone is more than all the components in this thing combined. And that's okay, because it depends on what you're trying to do. But I love this little machine as something that's fun and pretty darn accurate for what it is, easy to put together. You know, one of the coolest uses I heard about from folks is they put in one of those resist pens and they're tracing out copper clad with this machine to then acid etched into circuit boards. I thought that was pretty cool. Before we wrap up, I did want to show off some just close-ups of the machine. Some folks had questions about assembly and parts you need, so let's take a look. When you purchase the parts list of items that are in the first video description, you'll get the belt, you'll get the little pulleys here. Those fit straight on the stepper shafts, and you just need the M3 screws to fasten your steppers through the plate and into the angle. The end over here is just a 1024 screw. It's not a shoulder bolt or anything more precise. I found it works great. And then if you purchase the Z-axis platform, these are M4s. You're supposed to use 4 on each. I've only been using 2, which is fine. We'll include the little clamp and the fastener that attaches the cable to the Y-axis. And let's see here. I think that's about it. So folks, as always, thanks for watching. I appreciate the enthusiasm. I am so excited about ChiliPeppr. That's going to be the go-to interface. I'm excited to use it for that next machine with the linear rails and the ball screws. That's going to be a totally different project. Should be a good time. And yeah, I'm excited to hear about what you guys do with your Arduinos, with your Garbles. It is the coolest thing out there. Again, what we can do with the technology and how little it costs these days. It's a good time to live, folks. So with that, thank you for the comments, the thumbs up, the shares, the likes. Thank you for that last video getting to like 100,000 views in a few months. Really cool, folks. Take care. See you soon.